Hi everyone, let's walk through 3 examples of how to express a rectangular point of the form x comma y as its polar equivalent in terms of r and theta. So the first rectangular point we're going to consider is the ordered pair -1, 1. And one thing I like to do with all of these, because it will help us determine the correct theta value later on, consider the quadrant in which the given rectangular point is located. So of course the point -1, 1 is going to be located in quadrant 2. So that's something we're going to have to keep in mind later, because when we go to determine the correct theta value for our polar point, it needs to be an angle that lies in the second quadrant. So there are a couple of formulas that you need to know to do this. The first one is that x squared plus y squared equals r squared. And the other one is the fact that the tangent of that angle theta for our polar point is equal to the y value over the x value. So those, of course, are the x and y from the ordered pairs. I don't like to think of this in terms of an inverse trig function per se, because then you have to worry about that restricted range. We really want to think about the fact we know the quadrant in which we need to lie, and that's what we're going to focus on to determine our correct theta value. So for this one, we'll start with r. We're going to square the -1, square the +1 y value. Of course, this gives us 2. And we generally do go with the positive square root for our r values. Now for theta, we would have the fact that the tangent of this angle we're going to find is going to be the y value over the x. So tangent in this case of the angle has to equal -1. So think about the tangent values you know. The reference angle is going to be pi over 4. Remember, tangent of pi over 4 is a +1. The fact that tangent's negative, that's confirming the fact we know we are in the second quadrant where, again, you know, tangent is negative in the second quadrant. So if you think in the second quadrant, reference angle pi over 4, the angle, of course, has to be 3 pi over 4. So that means our polar point in terms of r and theta is going to be square root of 2, 3 pi over 4. Remember, I mentioned earlier, perhaps you remember, when it comes to writing these polar points, sometimes you'll see a semicolon used, sometimes you'll see a comma used. I grew up learning semicolons from my high school teacher, so that's what I always use. Um, Oftentimes in textbooks, you'll just see a comma. All right, so it's really whichever one you prefer. I like to do it because then I can easily differentiate what's a polar point versus what's a rectangular point. Now, if you were to think about the plotting of this polar point, remember we would start with our angle 3 pi over 4, and we'd have to be square root of 2 for the r, so that's about 1.414. So 3 pi over 4 is going to be over here. Go a little bit more than 2 circles out. That puts us right here, which, if you think of a rectangular Cartesian plane superimposed on that, that would be quadrant 2. Again, makes a lot of sense. So let's take a look at another one. Now we're going to consider the rectangular point 0, 2, which we know to lie on the positive y-axis. So to get the r value, remember our formula, x squared plus y squared equals r squared. So squaring the x, squaring the y, get that r equals 2. Again, we typically go with the positive root. Now to get the angle, we would know that the tangent of theta in this case would have to be y over x, but that's undefined. Think about if you have a point that lies on the positive y-axis, what angle does that correspond with? Hopefully you're thinking it corresponds with pi over 2, which would be correct. So our polar point is the point 2 pi over 2. Again, think about how that would look graphed. Pi over 2, of course, is up here. If we go 2 circles out from the pole, that puts us right here, which looks exactly where the rectangular point 0, 2 would lie in a Cartesian plane. The last one we're going to look at is the rectangular point -2, 5, and you are going to need your calculator for this one. Start to find r, square the x value, we'd have 4, square the y, we'd have 25. That means we have an r value of square root of 29. You can definitely leave it like that, that's fine. You want to have a better sense of the placement of it. The decimal for it is approximately 5.385. For the theta value, we'd have that tangent of our angle would be the y value 5 over -2. Now, as we spoke about with the earlier problems, this particular ordered pair, -2, 5, that would lie in the second quadrant. So again, when we figure out what our theta value is in the end, it does have to be an angle in the second quadrant. That's reflected in the fact that we have here a negative tangent value. So this is obviously one not associated with the unit circle. So that's why you need your calculator, because you'll need your calculator to determine the reference angle and then make our way to the actual angle we want in the end. Be sure you're in radian mode. So you're simply going to do inverse tangent and just do 5/2. Leave out the negative because we do want a reference angle first. So if you give that a try, you should find that your reference angle is approximately 1.190, and remember that's radians. Now in the second quadrant, remember to get our angle theta, we're going to do pi minus that reference angle. And when you do that, you should come out with approximately 1.952. So our polar point in the end, 5.385, and an angle of 1.95. So we can think about what this would look like graphed as well. So we have about 2 radians. And remember, 1 radian is about 57 degrees. So double that, almost. You're a little over 100 degrees. And remember, it's a R value of 5.35 approximately. So we're going to go a little more than 5 circles out. So that would put us roughly. And if you think about the original rectangular point, -2, 5, again, consider a Cartesian plane superimposed on top of this polar graph. Makes about sense. That would be about the placement of a rectangular point, -2, 5. So as we saw earlier when we were expressing polar points in rectangular form, there is a lot that makes sense in terms of the relationship between the two. So from here on out, hopefully you can try some of these on your own.